Hello. Okay. Hi, everyone. Welcome to the last session of the conference. Happy that you guys are still here, resisting with your coffee. Good to go. We're talking about multi-tenant search, and the key takeaways here is that there's quite a bit that goes into search in general, search engine, design of your search engine, and what I'm going to try to focus here is what are the types of things that you focus when dealing with multi-tenancy and search. So I'm not going to go too deep into search concepts and how the search works and things like that, but what are the things if you have a multi-tenant application, what are the things that you need to kind of be considering, and that is very tied up with which search engine you select. So there's different frameworks. I will touch on a couple of them. But for the most part, there are certain design things and how your application really is to say how that's going to fit into these existing frameworks or something that you build directly, for example, based on Lucene or something like that. I'm here kind of representing myself, kind of some of the opinions and views here are my own and not necessarily represent the ideas of Oracle. A little bit about me, I've been doing Java since 1995, since starting my career just about the time that Java came out. So it was kind of a nice merge of the timing just worked out well. So I've been kind of playing with Java, did quite a bit of applets back in the day, then the web specification, and been doing some kind of web development since then. Today I'm with Oracle Taleo. Taleo is, until a couple of years ago, was kind of an independent company that provided HR, recruiting, performance, onboarding features for a large part of very large companies in the United States. We have a very good penetration on that market, and we have two main product lines. We have the enterprise line, which is for companies that are 5,000, 10,000 plus employees, and we have the small medium product line, which is the one I work on, and I'm currently kind of the architect for that product in terms of kind of work with product, work with development, kind of provide some of the path of where we want our platform to grow within that. So this small medium business platform, we have about 5,000 customers. They vary in size. We have mostly a careers website, meaning that where candidates in the United States or whatever the company is kind of go to view and search for jobs, apply for jobs, and then there's the back-end UI that the recruiting managers go in to manage the applications and make offers and things like that. We also have a full REST API in the back end, and we do need to provide searchable capabilities for all these customers and all the things associated with those customers. Okay, I have one copy of the Elasticsearch server book here, so for whoever has questions, I will just pick someone, and I just want to hear questions and see if you have any feedback, not only questions, but your participation, I guess it's welcome, so we'll give that away at the end of the session. And here's the agenda. So I'm going to start a couple concepts, initial concepts of what multi-tenancy is. Not very quickly, just to kind of provide what are my contexts in terms of what does that mean to me, what multi-tenancy is. Then we go into designing the search engine, then setting up your cluster, how you want to serve that to your customers, and maybe the most important one is kind of how you integrate that into your application. So we want to keep in mind all the different things about multi-tenancy, that is people that are coexisting, sharing an environment, and at the same time, they should feel like they're not really sharing with anyone. There shouldn't be any noises or smells or anything from other tenants in that infrastructure. So just jumping into there. So multi-tenants to me, it's a lot like a big community pool, right? If every family here needed to build their own pool in their backyard, they would take a lot of money, they would take a lot of time, and they will actually be stuck with a maintenance fee every month. And their motivation is to get refreshed and play in the water, play in the sun, and they're not really interested in kind of having to maintain this pool just because they want to use it, So the fact that you can just go to a community pool and you pay a monthly membership somehow, at the end of the day, you kind of get the same benefits, right? You get refreshed, you can get to play, you can get to enjoy it, and then you don't have to build, you can come at any time, it's ready to go, you can go and use it. And but it has a little caveats, right? I mean, here you might get like a ball hit in your face every once in a while with people playing around you. There's something, people can do something in the water that might interfere with your, with your experience. So So that's kind of the key thing here. So multi-tenancy, it allows sharing infrastructure, but at the same time, we want to be able to really kind of control how the experience of the different people using that happens. We don't want a bad tenant affect other tenants in your application. So this is a key concept that whenever we're creating this search cluster, we want to keep that in mind. I mean, we don't want to do anything in Siri. You don't want to have one customer, one tenant waiting for another customer, and those type of things. So in a very simplistic manner, it's a single software application that is hosting multiple, 2 or more customers. And that's kind of our premise here. So some of the benefits here, right, of this environment is you can share resources. You have usually a large footprint that otherwise people by themselves they could not buy, and that large footprint is shared depending on the demand of each of the people in the environment. It's lower cost for whoever is using, right? So you don't have to buy anything up front. It's usually just on as needed or in a contract on a monthly basis. It's easier to scale horizontally for the most part if you set it up right. People, when they buy, they can usually join in pretty quickly. The onboarding, again, if it's done right, it can be pretty seamless. It allows you to, at least for the provider, to aggregate data better, right? So I have all these people using the application in my environment. I can infer a lot of information from those users over time because they're all sharing that same environment. The release process is usually simpler too, just because it's one big application or a few of them that it's much more manageable versus different installations in different customers and for different customers and things like that. And it's green, which is cool because basically you're sharing, just using your resources better. You're going to have fewer CPUs overall, fewer energy consumption. So it's something that it really is aligned. As long as it's done correctly, it makes a lot of sense for whoever is using it and providing. Some of the pitfalls and risks, it's obviously when you allow people to share those resources, how do you limit the sharing, right? You don't want someone to take in all your CPU, all your memory, and affecting other customers. So that, I think, software has come a long way. Some of your OS now, the virtualization capabilities provide a lot of flexibility on that. Now even the database, Oracle 12c database release now, the multi-tenancy provided there allows you to set the memory space, specifically maximum and minimum memory space for different tenants, and things of that sort. So it's getting very formal, and very it's probably easier for people to spin up, a new multi-tenant application based on some of these infrastructure items. With that too, the level of customization, it's a little bit higher, right? It's not, at this point, it's one single application that needs to fit everyone's needs. You need to be conscious of different processes those companies go through and allow a flexible setup that they can change their workflows, they can change their life cycle and provide that. So that complexity, the customization introduces a little bit more complexity, right? So you have to have these more metadata-driven systems to some areas, and that's usually it gets a little bit more complex for maintaining and growing the system. And the security, I think that's kind of less in the list here, but not as less important, because more than ever now you have data from different customers coexisting, and this needs to be treated very carefully in terms of how that data can intermix. That should not be intermixed. Your sessions should be very specific to the customer that you're providing the service for. Okay, so from a topology perspective, when you're setting up a new search, you start with your application, right? And somehow you introduce a new search engine, right? So your application is going to be talking search engine that it might be in a separate physical machine, or it can be in your own box, dependent. It's up to you. But basically, you're going to be sending things to be indexed, and you're going to be querying later on. And the point is that search engines are very good at indexing and allowing you to search on that. But the search engine, it's a whole lot more than that. So when we look into that, a search engine will be a collection of nodes, and each collection of nodes will be your clusters, and you can have one or multiple clusters, and the orchestration of these clusters in your network, you might require a hub, and by a hub is just a locator of which customer is in which cluster, and there's quite a bit of stuff that goes into that. So the hope today is that I can touch on a few of these points and then kind of provide some some insights of how we solve that problem. And the solution we have in place today is based on Lucene, and it has been developed a few years ago, and today we have 3 large multi-tenant systems that leverage some of the patterns we're talking here. But since then, there's a lot of open source goodness that has come up that solved a bunch of problems that we have to solve by hand, and I'm gonna try to kind of compare and contrast those two. Okay, so first we're gonna talk about specifically how do you design your index, right? What's the right level of granularity when you work and create your indexes, your actual Lucene indexes or whatever is your tool that you're using. Then how do you actually put together, what is the things that you need to take in consideration setting up your environment in terms of clustering, replications, and things like that. And the third one is really kind of how your application, how you should engineer your application to talk to that system. Okay, so the key initial question here, and sometimes it might be a very obvious answer, but I think there's still a process of kind of asking yourself, what's the right level of granularity for my index? And what I mean by that is that, okay, should I have one very, very large index with all my customers' data in that same index, and I just make sure that every time I search, I key off my tenant ID, right? At that point, and I can expose only to my customer that search, so the security can actually be enforced there, but I also can search across all my customers, which is very powerful, right? Because it's one big cluster. So that might be a good idea or not so good idea. If you have too big of a cluster or too big of an index, it might not fit in one physical device. You know, it might your biggest drive, or it just might be too big. Versus really segmenting your index. I talk a little bit about pros and cons. In the segment, you can segment your customers in different index. Or you can even go further. You can segment your different entities for your customers as different indexes. So there's a whole spectrum of the variation there. And I think it's up, you have to have a conversation, understanding your application, how it should be used, and the framework that you use, it's going to go a long way, right? So for example, Elasticsearch has a bunch of capabilities around creating shards, right? Which is, even if you have a very large index, if you create the different shards, and we'll talk about that, it might allow you to spread those up in different nodes. So let's keep going. So if you have any questions, just please raise your hand anytime. All right. So the share indexes for the most part, okay, they're schemaless. They're basically shared for all the customers. You're gonna leverage a schemaless index. Basically, you're gonna leverage flex fields that any customer can have any number of fields. They don't have to have the same structure of your entities, and they can all be put together. So I can really perform a search, and then from that search result, I can get different types of documents back. I can get a candidate, I can get an employee, I can get an order, I can get everything's kind of mixed together, which might be or might not be what I'm looking for. It's really the true global search. I can search across orders from all my customers if I wanted to. And you get those intermixed results. So the cons is that all the data from all your customers are all really bundled together, right? Even at the file system, they're all kind of right there, sitting in the same index. It's very weak data separation. If you have corruption in that index, basically it's bigger chances that affecting your search as a whole, right? Because it's not going to be just one section of your search, since everything's based on that. But again, there are some ways to get around that if needed. But just in general, that's kind of the general ability. When you actually, one of the most expensive things on the search is really indexing data. And in a Lucene, you can only have one thread with the index open at a time, right? So if you have those 5,000 customers, or how many you have, trying to update data and changing that index, that can really create a bottleneck that for you, and how you can push that into a Lucene index, right? So that's something to keep in mind. So when you have dedicated indexes, right, so the data is better separated. So actually in the file system, they will be in different locations, and you can specify, okay, my customer A, it's in this directory, customer B in that directory. You can actually put them in different volumes if you want, depending on how you mount those disks. So all of a sudden, it's a little better. It's more modular. I can move my customer on North America data center to my European data center. It's going to be a pretty seamless activity, because their data that file is just their data. I don't have to actually extract and delete from the large index or anything like that. Again, when I'm indexing, I can just have those requests are not going to be they can be more better parallelized because I have different indexes and they all accept one at a time, so to speak. With that, you're going to have a little bit more storage. You're going to need a little more storage of that because every time you replicate an index, so the word in an index is only occurs once. So if you have multiple indexes, that word is going to be in all those different indexes. So it's a little bit more storage, not a whole lot, but something to keep in mind. And then the global search is a little bit more limited if you want to do that. However, Elasticsearch also solves that. It allows you to join different indexes on the fly. It even allows you to join different clusters on the fly, which is amazing. So, all right. So a little bit now in the indexing process and even deciding to store or not in the document. When you have you have a pointer here. Okay. So when you send a text to be indexed, there's a number of things that take place, and this is really what's expensive about search. The query itself is very trivial because the work has already been done. So when you submit a search, it really tokenizes all the different words, and it clears out all the words that we don't care about searching about, which are called the stop words. So at the end of the day, when I'm sending that large string, I'm really keeping droid and look at the end here in the example, meaning that the actual size of the index is going to be much smaller than the document that was sent in, right? And that's what you need. That's the bare minimum you need for performing a search. But you can ask the search engine to actually store the original document in the original form. So basically, for whenever it's searching, it really doesn't use the original one. It will just do a lookup of the pointer of that map, and then it will find that document and send it back. So what are some of the pointers around that? So at the index itself, I'm going to have the different tokens, and it's going to be only one occurrence of that token at a time, and just a list of pointers to the original documents that included that token. Okay? So for example, if I search for droid, I'm going to have 3 matches to document 1, 2, 3. So search for look, I'm going to have only matches on 2 or 3, and that's really basically at the core how it's kind of how it's done. So when you have storage enabled, that means that the original document that you sent in, it was kept on the search engine. Whenever you get the results, you can pick to actually retrieve the full document, and that's pretty cool because what that means is that when you take the results, you don't need to go back to your database and fetch that information, right? But that means also that everything that you ever send to the search engine that data will be double between your database and your search engine. So storage has been becoming less of a big deal. So this sounds like a reasonable way to go. So the alternative is really just keeping the index. The data is in my database. Give me the IDs back. I'm going to go to the database and pull that before I render on the screen. Okay. So some of the pros and cons of doing that. So I kind of mentioned a couple here. Whenever you want to avoid going to a database, what that means is that your ACL needs to be on the search engine too. So that's going to make, and by that I mean, so this person who is searching has the access to this document that I'm retrieving. And that means that whenever you're searching, you need to kind of enforce that at the time of a search. So that means you're going to have to send more stuff. Your index are going to be a little bit more complex. So I listed there as here at the bottom, an access control needs to be built in the index. That's kind of sometimes it's a hard thing. Depending on how your ACL is put together in your application, this might be not as trivial to do. And also has the fact that some data takes a while to index. If you don't have real-time indexing, basically you can have access control change in the database, but has not yet propagated in the search. So you might be able to still find search results that you really shouldn't have access to. So depending on the level of security that you need to provide and the kind of data that you have, this might or might not be a good idea. The snippet highlighting, it's also, if you have the data there, whenever you get the results, the search engine can actually highlight the parts that match the text, which is pretty cool. And otherwise, just having the IDs, it's pretty lightweight. Your index is really just doing the job it's supposed to do. Just search, get me the IDs, and I'll deal with the IDs by applying ACL, doing the highlighting with text from my database, and those type of things. All right? So another one, whenever you define your indexes, take advantage of parent-child relationships. What that means is that when I send a document that has multiple other sub-entities, you can kind of really segment those as different indexes in your application. And that means if you have an entity, a sub-entity that changed, you don't have to send the whole document again. So if you really segment your indexes correctly, and you have certain things that change more frequently, you don't have to resend more data than you're supposed to. So that's something to keep about. So in the example here, I have a customers with orders, and whenever I'm sending a new order, every time a new order is placed, I don't want to send a whole new customer with a list of orders. I can just send the order separately or update my customer separately. I don't have to kind of bind the two directly. And this is, again, how you set up your index and the structure between that. Multiple languages. A lot of search engines provide language detection, and that's extremely valuable, because when you detect that language, you can apply the stop words for that language, and then you can clean up a bunch of noise from your index, so you don't want to store that. And whenever you do stemming in some of these languages, that might not be as good as for example, in an English language versus stemming in some other different language. So that's things that you need to kind of keep in mind whenever you're dealing with a single index in multiple languages. And one option is actually something that we do use. We have, for example, you have a title field. We actually index the different languages all in that single field. So if you submit a word in English, or that word that in the title in French or in another language, they're all going to match up. And we're just going to render the results to you in your local language. So you can actually search in different language, but get the results in the language that you currently have selected. And that, from an index perspective, it's very simple, because it's just a text field with all of them, and we get multi-language support. All right. So now looking a little bit more on the cluster side, what are kind of the things that we need to talk about? So the term shards, right, this is kind of how some of the search engines solve the problem of parallel searching and kind of breaking into smaller pieces and bring it together, right? The MapReduce kind of concept. So when you define your index, you can define the number of shards that is available in that index. And that means if I have this node 1 with, this is one index and has 5 shards, that means that there are 5 Lucene indexes on my disk. And when I perform a search, those 5 searches can happen in parallel in those 5 chunks, and then they're merged together into one big results and sent to me. So it's actually a pretty powerful idea. And then when you add a second node to your environment, we automatically have the ability to kind of have some of these shards migrate over. So that means that now whenever I perform a search, I can actually split my CPU needs between the 2 nodes, get the results merged back together, and send it back. But the problem is, if one of these nodes go down, basically my search is no longer complete, because some of my shards are missing there, right? So you don't have the high availability capability just with sharding. But if you go in replicas, it's kind of the same setup. You have your 5 shards between the 2 nodes, but you set up your replicas. That means that they always kind of they really replicate it in the respective node, right? And if you have more nodes, all these things kind of played out accordingly. So in this case, if one of your nodes go down, the replicated ones in the remaining nodes are going to become primary, and you're still going to be up. Basically, that's the high availability capability and this is a lot of these are just directly taken from Elasticsearch capabilities, and you get out of the box. So very powerful. All right, in terms of clusters, clusters really is just a collection of nodes that are put together. You don't have to have more than one cluster. There are different reasons that you might have more than one cluster. Elasticsearch provides you cluster support right out of the box, so it's pretty straightforward. When you're looking at clusters, why would you want to do it? Maybe you have different production environments, and you want to match one cluster for each production environment. Maybe you have different data centers, and you cannot really have a cluster serve you across the ocean or anything like that. So that's why you have different clusters. But there's 2 ways of, if you need it, search across clusters, and that's a very powerful thing. So keep that in mind as you kind of go through that. And hub. So this gets a little bit more of how we solve the problem. For multi-tenants, basically we didn't want to also hardwire this tenant in this cluster or that tenant in that cluster. This is all done dynamically. So every time our application is looking for where to search for that customer, it does a lookup on the hub. It gets the specific cluster that is hosting that, and then it goes to that cluster specifically. So it's almost like a discovery mechanism for us to handle the cluster. And we can move customers from one cluster to another, and that happens pretty seamlessly. So this is a general idea. Someone is trying to perform a search, the application goes in and sees if it has the location of on the search for that customer specifically. If it doesn't, it goes to the hub. The hub provides the location, and then we go directly to the search cluster that we got from the hub and perform the search. So there's some caching that you can do there, but basically we can move that customer around, and from a search perspective, the application will always auto-discover. Whenever we're talking about integrating with the system, the key question is, what is the effort? What is expected? Is your application a search-heavy application, or just a lot of people are going to be searching, and there's going to be fewer writes versus a lot of writes in eventual searches. So that's kind of the ratio is pretty important how you dimension your integration. The key takeaway is that writes are very expensive. So you want to bundle your writes together as much as you can. Every time you try to index anything on the search on the cluster or on an index, there's a process of opening up the index, writing, and closing, and there's a merge that happens and a purge, and there's a lot of stuff that there's no way of getting around that. So you want to bundle things together. So for us, at least in our experience, the biggest tuning process was around making our indexation fast. The search was never an issue. Having people search and retrieve was never an issue. So whenever you're doing the initial load, right, you just rolled out this search, or you do a full bulk load, just making sure that you try to bulk things as much as you can. So send really big data sheets with many entities together. So in your indexing process, really okay, let's open this guy up, let's dump these 1,000 entities here and close, and do chunks of thousands versus one at a time. So that would be like night and day in terms of performance response. Consider versioning it's a key one here. It is also available in Elasticsearch, is that if you're pushing to your search engine from different parallel systems, the order that they're going to receive certain entities might be different. So if you have something that's been in the queue for a long time and something more recent got that first, you don't want the old one to kind of come behind and update the newer one. So if you just define a versioning when you're sending over to your search engine, that means that even if it's a timestamp or what have you, so if I'm getting an older version of a timestamp older than the one I have, I'm just going to ignore that and consider that was out of sync. And again, documents will sometimes fail to index for some bad character, bad formatting, or what have you. Keep track of those and resend, and keep track of, I guess, try to resend them, see if that corrects. It could have been a network problem or something like that. But if not, look into specifically what are the reasons that it failed. But the key thing is that you never want to have to re-index again from scratch, because you're going to be sending hundreds of gigs or terabytes of data there, and just that process, it's very lengthy. It could be days or like hours or days. All right, so a little bit on incremental indexing. So basically, your application, there's a search by the user. Your application saved that to the database. Instead of just sending to the search engine, it just put in the message queue. So that means your application doesn't care that the search is up. It's not going to deal with that. It's basically going to say, hey, there's a job here to be done in the queue. As soon as possible, please do it. So your application moves on, and your customer is done. The message queue will pick that up, and asynchronous is going to call your search engine ingest service. And that means it's a service just to take in requests and save it, and that's good because your indexing threads can be running behind, and you don't want those requests for new indexation to kind of lag. So basically, it's a dual asynchronous process. This to kind of provide you some extra support on if things go wrong, right? So for example, if my indexing thread fails, I can still take requests for indexation because I'm just going to be putting that down for now. My search is going to start getting out of sync, right? Because my system is moving, but I'm not updating the server. I'm not updating the search. So that's still good. So whenever this guy comes back, it's going to pick up everything that is sitting there, and it's going to catch up, hopefully. So if my file system goes down, then I'm no longer take new requests for indexations, right? So now at that point, it's a more serious problem. But then my message queue still should be able to handle that. So if my message queue tries to do a job and it fails, it should have some kind of retrying mechanism to kind of take care of that. At that point, if your message queue fails, then you really have a bigger problem. But hopefully, it's a clustered service that also kind of provides quite a bit of robust service for you. Okay, and then whenever your search indexing is down or running behind for whatever reason, and that will happen, there's a way to kind of message the customer, right? So, for example, here I have we show a warning saying that search results might not include recently updated tries. So whenever we detect there are things waiting to be indexed, we also tell your customers, hey, these are the current search results, but we might be a few minutes behind. So keep in mind that try again later. So we might be able to catch up by then. All right, disaster recovery. Again, take advantage of your framework, and I guess this is specific to Elasticsearch. It gives you all kinds of goodies right out of the box. It's very powerful. Whenever you're making some of these decisions of how you kind of segment things, if it is Solar, if you go directly to Lucene or Elasticsearch, just keep that in mind. What are the capabilities that you have at hand? One thing that we do, we really never want to have to reindex these things. So we have nightly backups, snapshots of our indexes that if anything goes wrong, we can also, instead of having to resend all the data to be reindexed, we can just restore from last night backup and then replay from the message queue from that time till now. So we can always be caught up. So it's a matter of just moving a file over and then replaying those changes that happened that day, and our actual work, it's really kind of redo what happened that day versus all time. So very, very easy and effective way kind of recovering from issues there. And yes, so always avoid starting from scratch. Yeah. That's right. The question is if after the message queue kind of sent through, the fact that it was already processed, it's already gone out of the message queue. But at least in our case, we have a historical image of that message queue for several weeks. So we just have a job that kind of goes behind and make sure that after they're marked as complete, so they're out of the picture, but we can also always go back and kind of manually reset them. All right, maybe. Yeah, I kind of heard you. Maybe just going to take the microphone.
How do you deal with the messages that are in the queue, and if the queue is broken, lost, some errors occur with the queue?
And you asking the queue on my message queue or the actual waiting
the data that is waiting to be added to the index?
Okay, yeah. Like I said, there's the message queue. There's one level that we keep a history of, and then we send that data to the search index to index, right? So if my file system fails, the message queue thinks that all those was sent successfully, right? But the files, they didn't make it through. In that case, we always rely on our message queue system to have a history of what was considered success and look by the time range, replay those messages that we sent, right? The idea is that if it was put in the queue, then we have a history that what the queue did. That's kind of part of the replication and the high availability of the message queue system.
Okay, that was the thing that I was asking. So it's the high availability of the message queue that takes care of this possible problem, right?
Yep. Yep. But it still requires us to go back and reset those queues, figure out which ones we need to be replayed. Okay, some final thoughts here. There's some of the new tooling, specifically Elasticsearch. They really make it easy to get this going. There were a number of things that you kind of had to bake in from scratch, and you no longer have to. So kind of take a look at that, and maybe start with the book I'm giving away. Consider carefully the granularity of an index, right? Maybe there's very few reasons that you shouldn't kind of segment your index as much as you can for your different entities for all your tenants, because you can always combine them later, and you get more throughput by segmenting more. Define your entities and their relationships exactly like you have in your application. Just try to mimic that in your search index. Not reason not to do that. Take advantage of sharding and your replication schemes to get your high availability on the search server. So there's fewer reasons to do. At the end of the day, those indexes are all files that are being accessed very, very frequently. Things will work for the most part, but I mean, disk problems, bad sectors, and things like that happen. Whenever you're setting up your cluster, make sure that you kind of take into consideration how would you potentially move those customers around, distribute that load. If you have, different levels of service, different SLAs, you can have a cluster for a certain SLA, different cluster, different SLA, those type of things. It'll be easier to kind of think of that ahead of schedule rather than later. And I guess, yeah, high availability, having those asynchronous process, even though your data is going to take a little bit longer to show up in your index. Meaning that the fact that you have an asynchronous process in the message queue, asynchronous process on actually indexing, the indexing threads, it might take a few seconds to actually that change show up in your search server. But that really kind of gives you the cushion to, if something goes wrong in that process, you kind of covered. So, and that's it. I think that's all I had. Any more questions? Yeah.
How long do you agree for the user to wait for it to be synchronized again? And did you consider prioritizing the data? Like I could imagine, like if something got deleted, it might be fast to delete it from indexed. Is it wise to like prioritize the data to be indexed?
Yeah, you can have your indexing threads, the ones that go and look for the files that are waiting to go. You can have different timeouts depending on the index, right? So if there are certain tables, certain data that you want it to be more eagerly updated in the search, you can do that. But it's still going to be something that will be asynchronous, right? And at that point, you can say, okay, this asynchronous, I just check for that file system every second. Chances are it's going to happen pretty quickly there. But yes, there's always a chance that for whatever reason, your cluster is running behind. It might be a minute or even more than that. So you need to be kind of cautious that if your customer can handle that, I mean, if you provide that information, okay, there might be something missing here that I cannot tell you about yet. We provide ways for them to kind of actually finding that in your database by browsing in your database, by basically just going to a list and ordering by date so they can actually find that. And saying that basically the search right now, it's a little bit behind. So it's almost like the search is really just the optimum way, the optimum experience. But if there's some kind of out of sync, we detect that and we give them kind of a way to go and still get the information that they're looking for.
Okay, thanks.
Mm-hmm. Okay.
Question about the indexes and the language recognition and the stemming you were talking about. So I understand that if you recognize the language, you can apply that. If you don't recognize it, you just make it the hard way, let's call it. Yeah. But, well, I was thinking about something similar for our system, but the problem I'm thinking of is if you've got a document that has more than one language inside. So we've got a few sentences in this one and a few sentences in a different one. And it's, from what I saw, it's quite common in all the non-English languages to actually introduce some English sentences in there. What can will it work? So basically, if the recognition doesn't work, will the indexes still work for that? Because on that part, we'll have to either take the wrong language or don't take any language and take the whole words.
Yeah, basically, the stemming is not going to take place on those words, right? But if the word happens to coincide with the word in the language that you actually auto-detected, right, then it might do the wrong thing. So it's really an interesting problem. But you could potentially identify some of these foreign words that appear more frequently in that language, and then just hint the search engine about those and how to treat those and stem those type of things.
No.
But that's going very specific there.
Are you applying the stemming also to the search phrase, so you basically have a straight match in the index?
Yeah.
So in that way, if you cannot apply the stemming to that file, you won't find some things.
That's right.
Okay.
Yeah.
Someone else? So thank you so much for your speech, Mr. Barros. And big applause, please.
All right. Thank you.